Hi everyone, and welcome to this session on Delta Lake with Azure Databricks. I'm very glad to be here at the summit, and I hope you are all enjoying your time at the summit as well. Quick introduction about me. My name is Mohit Batra. I'm a founder at Crystal Talks, which is into training and consultancy. I'm also an author with Pluralsight, so I do publish a lot of video content there, specifically on Databricks as well as Azure Synapse. I'm a Microsoft certified trainer, and prior to this, I have worked with companies like Microsoft and Saxo Bank. My LinkedIn profile is there on your screen, so in case you wish to get in touch, I'll be more than happy to connect with you. Great, so let's get started and let's see what is the agenda for today's session. First of all, we'll talk about what are the different challenges with data lake. Now, data lake is becoming the de facto storage. In fact, in most of the projects that I have seen, data lake is being widely used, and this is the place where we are storing the raw data as well as the process data. But obviously, whenever we are using a technology, so it does come with its own set of challenges, and we'll talk about what are the challenges we have in data lake. Then we'll also talk about what is Delta architecture. Followed by this, we'll try to understand what is Delta Lake, where, what exactly it is, where we can use it, and how exactly it works. And finally, we'll straight away jump into demos and we'll look into the different features of Delta Lake via demos. All right, so this is the agenda for this particular session. So let's get started and talk about what are the challenges associated with Data Lake. Now, before we go there and talk about the challenges, let me just quickly talk about the Lambda architecture. Now, this is a pretty typical architecture which is being followed, in a lot of different projects. So, what exactly it is? Let's say there is a lot of, there is a lot of streaming data that is coming in. Now, this streaming data is coming. It could be coming from different devices. It could be coming from sensors. It could be coming from log servers. So there are a variety of places from which this streaming data could be coming in. Now, this streaming data, what typically we can do, we can put that into, let's say, any stream ingestion service like Azure Event Hubs, from where, we can store it for a specific period of time, and then we can pick it up and process that. So how we can process it? Let's say one of the options, we can use Azure Databricks, and we can go ahead and stream process this data. So we can pick up the data from Event Hubs and we can process, we can do stream processing of that. Now, once this data is processed, so we can go ahead and store this processed data, now which is data that has been stream processed, we can go ahead and put that into data lake. And this is, again, this is one of our typical architectures. Of course, it's not like that we have to always follow that, but it's very typical architecture where we go ahead and store this processed data into data lake. And then, of course, from the data lake, any reporting tool that wants to pick up the data and create dashboards, charts, all the reports, they can go ahead and do that. For example, Power BI can pick up the data from Azure Data Lake, and then it can go and you can go ahead and visualize the data. Then on the other side, we also have got, let's say the batch data or the historical data. So what we can do, we can pick up this data. Again, we can bring in this raw data and put it into data lake. Now, again, this is something that we can, in fact, we can get this raw data from various different sources, which we want to process in the batch format, and we can bring this raw data into data lake. And of course, whatever data we are getting into Event Hubs, which is continuously streaming in, we can also bring that into data lake. Then once we have this streaming data as well as raw data, and we want to do batch processing, so we can again, let's say, utilize Azure Databricks and we can process that in batch. Once this data has been processed, we can again put that this process data, which has been processed by batch, we can put that into data lake. And then again, from here, the Power BI can go ahead and, we can visualize the data inside Power BI. So this is one very typical architecture, which is Lambda architecture, which a lot of companies follow in their projects. But there are several challenges which are associated with this. For example, that we have to now the data which is streaming inside Azure Event Hubs, we are kind of reprocessing that data. Now, one of the requirements, if you see here, is that we have to process the data in real time. So we are directly picking the data from Event Hubs. We are processing, we are doing stream processing of that data, and then we are putting that process data into data lake. On the other side, we have got, we want to do the processing of the data, let's say every 1 day. So we are not just picking up the historical data, but we are also going ahead and picking the data from event hubs, and then we are processing that in batch. So this means that we are now processing the data, which is the streaming data twice. So we have the data which is, which has been processed already. We are again processing that data by, kind of combining that with the historical data. So this is one of the challenges that we face while working with, the Lambda architecture. The second problem here is that, because all the data is present in data lake in the form of files. Obviously, when we have the data lake, the data is all in the form of files. So that when you want to do the updates or when you want to do the deletes, it becomes a very big challenge when you're working with data lake. Think about if you want to, incrementally update the data, or if you want to go ahead and follow the GDPR compliance when you have to, delete certain records or, update the records as well. So this becomes a very big challenge when we are working with data lake. Now, on the other side, what we can, what are the other challenges which are associated? Let's talk about that. Now, one of the biggest challenges that we see in data lake is about data reliability. Now, what exactly is that? Now, think about that, we are continuously writing the data in the form of files. Now, what will happen if, we are writing the files and in the midway, there is a failure that occurs. So in case there is a failure while writing the data, we now have written inconsistent files inside data lake. So that means that the data corruption has occurred and there is no mechanism that we can go ahead and roll it back. On the other side, there is a problem of data validation. So in case you are writing the data, we just don't know what kind. Of course, you can build up your controls inside your application or your processing engine while you're writing the data, but still, whatever data is getting written, we are not validating that data. Who is going to do the validation that what was the previous schema in the files and what is the new schema in the files? All right, so there is a problem of data validation, that what kind of data is going inside. Maybe we have some previous data there in the, in the data lake, which is, let's assume there is a column and that's an integer column. Now the next set of data that we are writing is, maybe it could be a string. So, this means that we have to build all these kinds of validations into our, data processing system, but there is no way to do data validation when the data goes into data lake. Then, of course, there could be a challenge of consistency. Now, what exactly is that? Think about that. There on one side there is one app, let's say one engine or one application which is writing the data. So let's assume we have a data processing system, so which is continuously processing the data and writing it to data lake. On the other side, there are business users or there are power users who are reading the data. If this activity happens at the same time when when the system is writing the data, on the other side the users are going ahead and reading the data, this can create consistency challenges, and it's a very typical it's a very typical problem of data consistency when we are working, when there are multiple processes which are working on the same set of files. Then there is another problem, as I just talked about previously, is the problem of updates, deletes, and merge. So whenever we have to write even a small change, let's say we want to go ahead and simply go ahead and let's say delete one record. So this would mean that I might have to read in fact I'll have to read the complete file in which the record is present, and then only I can go ahead and delete that. So this means simply doing the updates, deletes, or merge on the files, it's a very big challenge. And that is where that is where the data warehouses are pretty good, which can easy where you can easily go, and if you have a database you can easily go and let's say delete some records. But this becomes a very big challenge while working with data lake. On the other side, whatever data we are writing, there is no constraints that we can apply. Again, we have to build all these things inside our application or in our processing logic, but there is no constraints that we can apply on the files in data lake. And finally, if you have to, the query performance is also may not be good. Let's assume, as I mentioned previously, that let's say you want to read only a part of the file. So let's say I just want to read one record from a file. So I've got a 1 GB file. I want to read, let's say, only one record from the file. This would mean that I'll have to read the whole file and then only I can get that record out. So this may not be a very efficient way of querying the data, if we are just reading, let's say, a limited data from a file. Plus, the other problem is the problem of small files. If you are into big data, then it's a very common challenge of working with a lot of small files. So these are some additional challenges apart from the data reprocessing, as well as the doing any updates, merge or deletes. So coming back to the Lambda architecture, that if you have got, first of all, if you have got streaming data and if you have got, let's say, batch data, you may not be able to put them into the same set of files because they both work at a different frequency. So this is where comes Delta Lake. So this means, now let me show you that what exactly is the Delta architecture. Now Delta architecture is the one which we can build up using Delta Lake. Of course, we'll talk about in detail what is Delta Lake, but Delta architecture is the one which we can build up using Delta Lake. So if you carefully notice here, what we can do, we can now utilize the batch data that is coming in, the streaming data that is coming in, and of course we can utilize Spark, which has the capability to perform the batch as well as the stream processing. Now the point here is not about Spark. The point here is that now we can go ahead and store this data inside Data Lake in the same set of files. Now this becomes pretty interesting. This means that I do not have to reprocess that data. In fact, multiple, twice. So whether it's streaming data or whether it is batch data, I can go ahead and put the data into same set of files. All right. So this is one of the major benefits of using Delta architecture, that we are not maintaining two set of data sets inside Data Lake. We are only having one data set where we are keeping all kinds of process data, whether it is a streaming data coming in or whether it is batch data coming in. All right, so this is the Delta architecture. Now let's talk about, now we have understood that, the Delta Lake can help us build this kind of architecture where we can have a common data set where, if the streaming data is the same and the batch data is also having the same attributes, we can go and put them inside a single, the same set of files. Now let's talk about what exactly is Delta Lake. Now, Delta Lake, let's talk about that. So Delta Lake here is an open source storage layer that can help us bring reliability to data lakes. Now, Delta Lake is an open source component. You can go ahead and download that on your machine as well in case you are locally working with Spark, or you can utilize Delta Lake in, let's say, Azure Databricks, or you can utilize them in Synapse. In fact, there are a lot of different providers which are now supporting Delta Lake. So it's an open source component that can help you bring reliability to your data lakes. So whatever challenges with that we have discussed, that we can go ahead and solve with Delta Lake. Now you might be thinking that what kind of magic it is going to bring up. So let's talk about that. Now let's say that we have a Spark cluster and we have our storage area that where we are going to store the data. Now, first of all, let's assume that, or in fact, let's say that we have the Delta Lake installed on the cluster. So as I said, it's an open source component. You can go ahead and download and install it on your machine as well. Now, in the same way, the cluster that you will be using to work with Spark, there we are going to install Delta Lake. Now, what will happen? Let's say that we have read some data into a data frame. Now, very typically, let's forget about Delta Lake for a second. Let's say that we have some data in the Spark data frame. Now, what we can do, we can go ahead and write this particular, we can write this data in this data frame into the storage, let's say in the form of Parquet file. So it's a very typical way. We take the data frame, we can write it into the storage as a Parquet file. But again, the problems will remain if you're just writing the data as a Parquet file. Now, what is the magic that Delta is going to bring in? In case in case we are storing the data into Delta format, when we say that we want to store the data in Delta format, again the actual data will still be stored in the Parquet format. All right, so the actual data is still there in the Parquet format, but along with that, it is also going to store some kind of log here. And this is what is known as the transaction log. And this is the magic behind Delta Lake. All right, so only this transaction log you will see here that can do magic, can help us solve variety of problems that we have just discussed. All right, so let's talk about what actually goes inside this transaction log. Now, let's assume, let's say that we want to store the data into our storage or inside our data lake, and it's going to be there in the form of files. Just very typical. So we are going to store the data in the form of files. Now, when we store the data into Delta format, okay, or when we store the data using Delta Lake, number one thing is that first of all, it will go ahead and write the files. So basically, my actual data will be in these, let's say in these two files. So I'm doing Spark processing. I'm going ahead and I'm writing the data into my storage or my data lake. So there will be multiple files that will be written out. Now, this is very typical of Spark. It is going to write down the files inside the storage. So you can see here that let's say that the Spark has written down two files. But the other thing that along with this one, you'll notice that there will be another folder called underscore delta underscore log. So along with while storing the files, it is also creating another folder called underscore delta underscore log. Now, in this particular folder, a new file will be stored called, let's say, 000.json. Now, what exactly do we have in this file? This particular file contains a reference to these two partition files. So it will, this particular JSON file will say that, all right, I did one transaction, and as part of this particular transaction, I have written down partition file number 1 and partition file number 2. So this is the only information that is available inside the Delta log folder. So this is for one single transaction that two files have been written out. Now let's say that, let's say that there is a writer process which wants to further write the data, and there is a reader process which wants to read the data. So this will help us understand two things. Number one, that how does how does the Delta works? How do we read the data using Delta, and how do we write the data using Delta? Plus, if there are two transactions happening at the same time, how does it make sure that the data is consistent? Okay, so let's say that there is a writer process and a reader process which wants to simultaneously read and write the data. On the first case, let's say the writer process is starting up. So the Spark, you have started using Spark, you're writing the output. So what will happen? First, it is going to write the new output in the, let's say, partition file number 3. All right, so it is uploading the data, or in fact, it is writing the data into partition file number 3. On the other side, the reader process now wants to read the data in this particular, folder. So what it will do, if you are working with Delta Lake, so this reader process is not going to go ahead and read, directly these files. This is not going to happen. So what it will do, this reader process will first of all read the transaction log. So inside the transaction log, you can see that it will only find that there is a 000.json file which is available. So it is only going to read this file. Now inside this file, we understand that this only contains a reference to partition file number 1 and partition file number 2. All right, while the 000.json does not have any reference to partition file number 3. Now, what will happen? Now, this is how both of them have started. On one side, the writer process is writing the data, and on the other side, the reader process has only read 000.json. Now, as soon as the writer process will finish, it will now go and update the transaction log saying that we have, there is another transaction that has happened, and it will create another file called 001.json. This is the 001.json. In fact, 001.json is the file which is going to have a reference to partition file number 3. Now, on the other side, so this means that the 001.json JSON file contains a reference to partition file number 3. Now, on the other side, the reader process has only read 000.json, so it can only go and read. It will only read partition file 1 and 2. Now, just if you look at how this, how the reading and writing is happening, in case of writing, first the partition files will be written and then the transaction log will be updated. On the other side, for the reader process, first it will go ahead and read the transaction log, whatever transaction files are there. In fact, the log files are there, and then it will read the partition files. So in this case, if you can see that there will be no consistency issues, because only the data that has been committed by, only when you put this one, if you put this file, then only it will be considered committed. Otherwise, it will be not. All right. So this makes sure that we are only reading consistent data. So this is how, the transaction log works. Now, let's go ahead and look into some demos that, first of all, we'll quickly review our Databricks environment, and then we'll look into the different features of Delta Lake. So we'll also go ahead and compare, we'll see how it compares to the Parquet format as well. All right, so moving on to, let me straight away move to the Databricks environment. So here I'm inside my Databricks environment, and if you notice here, I'm just going to show you. So here is my the cluster, which is already up and running. I'll just show that to you. So here I'm utilizing Databricks runtime version 8.3. Now, what exactly is Databricks runtime version? Databricks runtime version is a set of libraries which are going to be pre-installed on the cluster. So when you go ahead and create a cluster, so you select a Databricks runtime version. Now, depending on whatever Databricks runtime version you have selected, there will be set of pre-install, there will be a set of libraries that will be installed on the cluster. Now, with Databricks Runtime 8.3, Delta Lake 1.0 has already been installed on my cluster. So this is the benefit of using Databricks, that you just select the Databricks Runtime version. Based on the Databricks Runtime version, a set of libraries will be installed. And with 8.3 version, Delta Lake version 1.0 will also be installed on the cluster. So this means I do not have to go and download the Delta Lake Delta Lake library. I don't have to install it on the cluster, because it now comes pre-installed with version 1.0 of Delta Lake. All right, so this is currently my cluster. It's a single node cluster that I have created here. So let's look into one of our notebooks. And this is where we'll start talking about, we'll look into the different features of Delta Lake. So there are a variety of features. It's not just the asset transactions, which helps us bring the reliability to data lakes. There are many other features which are available in Delta Lake. So we'll talk about, what we'll look into the transaction log. We'll also look into the comparison with Parquet format in terms of, performance, in terms of, what features or, what functionality it provides. Then we'll look into the audit history. So this means that whatever operations we are performing on, let's say on Delta Lake, we can actually go and review it, what changes we have performed. Then we'll see that how easy it is going to be to insert some data into into a Delta Lake table, how we can do the updates, how we can do the deletes, and how we can do the merge. So this means if you have if you have the requirements of GDPR compliance or any other kind of compliance for which you need to frequently do the updates or deletes into your data, you can easily do that with Delta Lake. Then we'll look into a very interesting feature of time traveling, and we'll see that how we can roll back to a previous version by using time traveling. And of course, we'll talk about some of the optimization features that can help our data lake, in fact, which can help our data lake files perform much better, or in fact, our code to perform much better. So let's get started by, I'm connected to the demo cluster that I just showed you. So what I'm going to do, I'm going to work with, certain, let's say the airlines data. So what I'm doing here, I'm going ahead and defining, the schema of the data that I have. So I have some airlines data in the form of files. I'm going to read that data. But first of all, I'm going ahead and defining, the schema of that particular file. So there are columns like year, month, day of week, airline, flight number, and then what is the schedule time, what is the elapsed time. So, we are getting some information about the airlines or any flights which are, which have been scheduled or which have, completed their journey. So let me go ahead and execute this particular cell. All right, so I have defined the schema here. So it's a pretty big file. and we have around 5.8 million records that we're going to work with. All right, so once we have the schema defined, now I'm going to go ahead and read I'm going to go ahead and read this particular file. So you can see here that I've got a file flights.csv, and I'm going to use the schema that we have just defined in the previous cell. All right, so let me go ahead and read this particular, I'm going to read this particular file called flights.csv, and I'm going to apply the schema, and I'm going to put that into a data frame variable. All right, so let's go ahead and execute this one. All right, so you can see here the data frame has been created. All right, now let's see what kind of data do we have here. So I'm going to use a display command and see what data we have in this particular data frame. So you can see here it has, the year column, there is month, day, and then there is the different airlines which are there. So these are the, the initials of the airlines, AS, AA, US, double, so these are the different, abbreviations for the airlines. Then we have the flight number. So this is going to be my actual flight number. Let's say AS98. Apart from this one, what is the origin airport, what is the destination airport? So we have that information as well. And let's see. So we have the departure time, departure delay. Let's see. There is a schedule time, and how much time it took. So that kind of information, plus what was the distance it covered. Then what was the scheduled arrival, what was the arrival time. So a lot of information is available to us. Then on the other side, I just want you to focus on this particular column, because we'll be working with this particular column called cancelled. All right, so right now we can see that the data that we are seeing here, almost all flights have completed their journey. They are not cancelled. So let's look into now that we have the data that we have read. Let's say if I have to write this data into, let's say, data lake. So what I'm going to do, I'm going to write this particular data set. So I have the airlines DF data frame. I'm going to write this particular data frame, inside my, I'm going to write it into data lake in the form of, in the Parquet format. So you can see here, I'm going ahead and I'm writing the data in Parquet format into data lake. Then I'm also going to partition the data by airline. So this means all the data of AA Airlines, or all the data of, let's say, AS Airlines or US Airlines, they're going to go into the same folder. All right, so let me go ahead and execute this one. So just give it a few seconds. So this is going to go ahead and write the data into the data lake. So it will take a few seconds. It's going to write the data in the form of Parquet format, and it's going to be partitioned by airline. And so let's just give it a few seconds. So this is going to go ahead and write the data. And meanwhile, I'll just quickly show you what we are going to do in the Delta format as well. So now this is the way we are writing the data into, in the form of Parquet. On the other side, I'm going to go and write the data into Delta format as well. So let's see how we are writing the data into Delta format. It's a very, very similar syntax. So you can see here, I'm writing the data, again, the same data frame, airlines TF. I'm going to go and overwrite the any existing folder or the files which are there. Remember, and what is the difference? The difference here is we are saying format is equal to Delta. In the previous case, we have mentioned that format is equal to Parquet, but in this case, we are saying format equal to Delta. Now, this is the only change that we have to do while writing the data into data lake. So in the previous case, it was Parquet. In this case, it's going to be Delta. So you already know that when you write the data into Delta format, this would mean that, again, the data will be written in Parquet format, plus there will be a transaction log. All right, so let's quickly go and verify that. And let me just take you to my data lake folder. So here I'm inside the Azure portal. So I'm going to show you the folder, the files which have been written out. So there is a flights output folder, and there I can see the option, the folder that I wrote the data in the Parquet format. So it's a Parquet. Let's go to this one. So the data has been, and you can see here, the data has been partitioned using airlines. So airline equal to AA. Let's open it up. And there you can see the 5 files have been written out. And it's these are pretty small files, approximately, on average, it is around 3 MB. So these are the files which have been written out. And this is the way all the data has been written. On the other side, if I show you, the Delta format. So let's go back and let me go to the Delta folder. All right, and there you can see once again there is airline, the data has been partitioned. So very, very similar data. I can go to airline equal to AA once again. Again, I can see there are 5 files have been written out, and it's almost, yeah, it's having actually, approximately the same 3 MB of data on average. So it's a very similar way the data has been written out. But now comes the magical part. So let me go back to the Delta folder. And there we can see that there is a folder called underscore delta underscore log. So if I go to this particular folder, so this shows me that, there is there is a file with CRC extension. Just ignore that for now. But you can see there is one file which is in JSON format. And this is the file, this is basically the first transaction. So we are now keeping a track of whatever transactions have taken place. So if I go and open up this file, let's see what do we have in this one. So let me go to edit here. Okay, and now you can notice that this is the information about the commit. So this means that now one transaction has been committed. So you can see at what time the transaction was committed, which user committed the transaction. I can see my email address showing up here. Then I can, so basically whatever operation has been performed, let's say operation parameter, so it's an override, plus whatever partitions have been created, that information is also present. So now going back to the, Databricks, so we have now written the data in Parquet format, which is pure Parquet files, no log, transaction log information. Then on the other side, we have written the data into Delta folder, which is basically, having the, which is having the transaction information. Now let's move forward and let's quickly go ahead and create a Parquet table here. So what I'll do, I'll use the existing data files and I'm going to create a table inside, Databricks. So let me first create a database here. All right, so I've just created a database called Airlines DB. And now I'm going ahead and I'm going to create a airlinesdb.parquet table. Now, is it actually like a relational table? No. So if you're coming from the, from the database word, this is not like a relational table. Remember that when we are creating this table, it is only a reference to the files in data lake. So what we are only doing, we are creating the metadata, inside Databricks. So notice here, I'm creating the table and I'm using this particular path. So this means that my data will still be there in the data lake, but now I'm creating the metadata inside Databricks. So let me go ahead and create this particular table. And this is going to create a new table called airlinesdb.parquet, which will refer, to the data present in this location. Now let's see how much data that we have here. I'm going to quickly run this one and it will go ahead and tell me that, how many records are present. So just going ahead and looking into the data and telling me that, it's going to tell me that how many records are there. Now, if you notice here, it tells me that, we have approximately 5.8 million records. Now, in the same way, I'm going to go ahead and create the Delta table as well. So once again, if you notice the previous command, we are saying create table, and we are saying the format of the data is in Parquet format. In fact, it is there in the Parquet format. Now, if I go and if I want to create a table which is based on Delta format, I'm going to say let me create a table called airlinesdb.delta, and I'm going to use the Delta format. So this would mean that now Databricks will know that we have a table, or in fact, we have created a table which is basically based on Delta format. So whenever it has to read the data, first it should read the Delta log, and then it should read the files. All right, so that is the only difference we have while creating the Parquet folder, or in fact the Parquet table, base table, and the database table. Again, let me just check how many records are there, and we'll just quickly verify. All right, so we have got again 5.8 million records. Now notice the time here. It took less than a second to get me that how many records are there. I'm just going to run it once again. Let's see how much time it takes. 0.34 seconds to tell me that there are 5.8 million records. On the other side, let me go and run this command on the Parquet table and see how much records we have, or in fact how much time it's going to take. So you can see it's slightly taking more time, and it took approximately 6 seconds to tell me that there are 5.8 million records. Let me do that once again. All right, so let's see how much time it takes once again. So it's taking approximately 2.6 seconds, but if you look at the delta table, it only took 0.34 seconds. Now you might be wondering that how the delta table is so fast. Let me show you, what exactly is happening behind the scene. So let me go back to the, once again to this delta log folder. Now, this is one single transaction, so we have the JSON file for it. Now, along with keeping that, what is the along with keeping that what is the files which have been written, it also contains the statistics information. So for example, if you look at the first transaction, it is going to tell me that how many number of records have been written here. So I'm just going to go and look at the number of records. All right, so just notice here the number of output rows. So it clearly tells me that, just by looking at the log, I can figure out that there are total 5.8 million records. So I don't even have to go to individual files and count the number of records. It is straight away telling me, the log is telling me that there are 5.8 million records. Plus, now this is at a transaction level. Along with this, I can even go and figure out that what is there in the number of records are there. Plus, for each and every column, it is going to keep the minimum values, maximum values, and it is going to keep the null records. So let's say, I have, let's say, a cancelled column. All right, so cancelled, cancelled is the flight status. So let's say that is one column. And if there are any null records, it will show me that, okay, there are, let's say, 100 null records in this particular column. So this kind of information, it has been kept in the logs. And this means that now, we don't even have to look inside the file. I can by just looking at the statistics, I can find out this information. So straight away, by using the Delta Lake, we are now getting the statistics for each and every, for the transaction level, plus at the individual file level, what are the for and at the individual file level, what are the minimum values in each column, what are the maximum values in each column, and what are the null records in each column. So that is something that can help us, quickly run our queries. All right. So that is the reason that, if we look at the count, the time which it has taken to do the count is much, it's much faster in case of Delta table as compared to the Parquet table. All right. So approximately, 7 to 8 times faster. Now let's move on and see that, what else we can do. So far we have seen, we have the information, it's performing well, the queries are running well. Now let's see that what else we can do. Let's assume that we want to go ahead and append the records into Parquet table as well as, the Delta table. Now the Parquet can easily supports append, because in case of append, you don't have to read any existing file. You can simply write a new file. All right, so let's see that. So here I'm going ahead and I'm reading another file called flights underscore append.csv. And, I'm just going to append few records, to both the tables. So we have the Parquet and the Delta table. In both of them, we are going to insert, in fact, we are going to append 3 records. All right, so these are the 3 records you can see in this particular file. And I'm going to go ahead and append these records into both the tables. So it's a very simple, it's a very simple way. So what we are going to do, in fact, let me just, so what we are doing here, we are saying that, okay, this is my data frame that we have just, created, airlines append df. I'm going to go and say airlines append df. I'm going to write it in the Parquet format, and I'm going to append it into the same location. So basically what I'm doing here, the Parquet table is already there. I'm inserting some additional records there. Now you can see it has already run and it has appended the records. In the same way, I'm going to go and append the data. Once again, the very similar command. We have the data frame. All right, we have the data frame. We are saying dot write function. We are saying format is equal to delta. Again, do the partition. Mode is going to be append. All right, so both of them commands are very similar, except the format in the previous case is Parquet. In this case, it is delta. So let me go ahead and run this particular command. So both of them have now appended 3 records. So if we want, we can quickly cross check that as well. Again, this is going to be much faster in case of Delta because obviously it will read the statistics. All right, so it's going ahead and reading. So earlier, let me show you the previous count. So the previous count was ending with 079. All right, and the new count is ending with 082. So this means 3 records have been successfully appended here. And in the Delta table as well, we can go ahead and quickly cross check that how many records have been appended. So once again, it is 082. So 3 records have been successfully appended. Now, let me show you that what has happened in the transaction log. So let me go and use a command called describe history command. So we are going to describe the history of this particular table. Now remember that this particular command is only applicable to Delta tables, not to any other kind of table. Now, if you notice here, we have now the audit history available of Delta table. So we are now clearly tracking that what are the activities that have happened on this particular table. So notice here, there is number one, in fact, see here the version number 0. This was the first time when we write, when we have written any data. So if you remember the first transaction we used the overwrite mode to write the new data. Next time we have used, when you see the version number 1, we have now did the append here. All right, so we are now keeping the complete track of what is happening on my table. So let's move and see, let's go and see more details about it. So if you notice here, let me just show that to you. In the previous case, when we did the, transaction number 0, it actually went ahead and updated. In fact, it created 68 files. On the other side, and when we have just went ahead and updated the data, we have only appended one new file. And how many number of rows we have appended? We have appended 3 rows. So we have now collected the information that what exactly has happened here. All right, so if I go back and show you the transaction log, okay, let me just close this one. Let's refresh. All right, so now you can see here there is the transaction number 0 where we did the first operation, and now we have the transaction number, transaction number 1. Let's see what do we have in this file. So this means for every transaction that you are doing, there will be a new file that will be created. All right, so let's see what is there. So this is showing me that there is a new file that has been added, and this is the location of that file, or in fact this is the full path of that file. And let's see how many records have been inserted. So I can see here total 3 records have been inserted. Now this is the second operation we have performed on the Delta Lake table. Now this append operation is applicable on the Parquet table as well as on the Delta table. And we have seen the audit history, so we are maintaining every bit of information about what has happened on my table. Moving on, let's quickly compare the performance. So you have already seen that we have got statistics. So and now what we are going to do, we are going to make a very specific query. So let's see what is that query. So what I'm going to do, I'm going to first of all query the Parquet format, in fact the Parquet table, and I'm going to say year equal to 2015 and month equal to 1, day equal to 1, and flight number equal to 98. So I'm going ahead and making a very specific query. Now notice here that the data is partitioned by airline. But what we are doing here, we have not included the partition information, or in fact, we have not utilized, we have not specified that which airline we are searching for. So this would mean it will have to search all the files which are there in all the folders, okay, or all the partitions. It is going to look into all the files and give me the output. So let's go and run this one. So in a Parquet format, because we don't have any statistics or we don't have any log, so it is going to scan all the files present inside the inside the folder, and it's showing me that this is the data for that. Now, if you notice here, it took around 5 seconds. This is point number 1. Second, it is giving me some information here. Now what is that information? This says, it says that this query contains a highly selective filter. To improve the performance of the queries, convert the table to delta. So it is telling me that, if I convert it to a delta table, this would be much more beneficial. Obviously, the business users are not going to do it. We as develop, if you are working as a developer, you can go ahead and convert it to a delta format. All right. Now let's go and we'll talk about the other part a bit later. So first, let's see that if I run the same query on the delta table, all right, the same query with the same conditions, I'm going to go ahead and run this on the delta table, and let's see how much time does it take. All right, just notice here it took 1.96 seconds, and the previous query took approximately 5 seconds. So straight away we are getting approximately 2.5 times performance benefit by writing, by just using the delta format. And why exactly, how is this happening? Because we have got statistics available inside the, we have statistics available inside the transaction log. So it is utilizing that. If I say, for example, year equal to 2015, it will look at the transaction log and see the statistics. If if a particular file has a minimum value of 2016, all right, so if a particular file has a minimum value of 2016, simply that file will be ignored. Now that is pretty beneficial because we are straight away eliminating the files which does not contain the data. All right, so this is how the performance, we have increased the performance if there are any specific queries. All right, so now let's see another benefit of this. So we have understood, the performance is pretty good while counting the records. We are while kind of in fact, while running a specific query, plus we have seen that it is maintaining statistics, so it's much more. We are getting the audit history of the table as well. Now let's see one thing which is not possible to do in the Parquet format. So if you want to, let's say, update a record, or if you want to delete a record, this is not possible in Parquet. What you will have to do, you will have to read the whole Parquet data. Then you have to go and kind of filter the data which you want to delete, and then you have to write the data back. This is not a very efficient operation. This is where comes Delta Lake, in which you can actually go ahead and delete the data or even update the records. Now think about, if you have, if you're in your project, you want to build up, of course you may have to follow GDPR compliant GDPR guidelines, or to make your system GDPR compliant, you have to go and completely remove the records. And of course, if there are too many frequent operations happening, or too many frequent updates or deletes are happening, this will be very challenging with Parquet format, but this is very, very easy while working with Delta. So let me just show you that how we can do that. So what I'm going to do, I'm going to read a few more records from a different file, called flights underscore delta. When I say delta, it's obviously not the Delta Lake I'm talking about. It's basically, a certain set of records that we are going to update or delete. Okay. Now just notice here, I'm going to read this file and let's see what do we have in this one. So we are going to read a few more records. So I'm reading 4 records, and what is the change that I'm going to do? Basically, the data which is already present in the data lake, that has a cancelled status of 0. But what I'm going to do, I'm going to go and update these 4 records with a cancelled status of 1. Okay, so I'm going to update the 4 records with a cancelled status of 1. Now let's see how we can do that. Let me just go ahead and, so we have created the data frame airlines upserts df. So I'm going to go and say airlines upserts df dot write dot save as table. So I'm going to create another table for this particular, the kind of the delta data. Okay. Now let me just check. Let me run the SQL query. Select star from airlines db dot upsert data. So this will show me that, okay, these are the 4 records that we are going to update. Now, this is where, there is another interesting aspect called merge query. Now, merge query, if you are coming from the relational database background, this would look very, very interesting to you because the syntax is very similar. So what I can do, I can create this particular merge statement. And notice here, I'm saying merge into airlines db.delta. So this is going to be my target table. All right, then we have the using airlines db.upsert data. So this is going to be my source. All right, so we have the source, we have the target, we have defined in the merge query. Now, on what column basis we want to go and merge the data? So these are the conditions on which I'm going to merge the data. So I'm going to compare it on the year, month, day, flight number, and the airline, and then I'm going to update the record. All right. So it says the condition says if in fact the query says if the condition is matched, then I'm going to go and update the cancelled status. All right. So this is for the demo purpose. I'm only going to update the cancelled column. So I'm going to say that let me update the cancelled status. If the record does not exist in the target, then I'm going to insert that. So this is a very simple and interesting way. So you can use that in SQL, you can use it in PySpark, you can use it in Scala. So basically all the APIs are available. But since the SQL looks much more simpler, so we are going and doing that in the SQL format. All right, so I'm going to go and run this command, and this will go ahead and update the data into the Delta table very quickly. All right, so I don't, I have around 5.8 million records. So it is not going to read all the 5.8 million records. In fact, it will find out that where is the record, and it's going to, it's going to, update that. Now, update works in a very different way inside, update works in a very different way inside Delta Lake. So it's not like that it's going to update the record. It's kind of a, a delete and insert operation. All right, so I'll just show that to you. So basically you can see here the 3 records have been updated, and 1 record was not present, so it has been inserted. Now, if I go and look into the Delta, once again, let's see the history here. So I'm going to describe the history on the Delta table. So you can see that the merge operation has been performed. And if we scroll to the right hand side, I can see that there is a number of target rows copied. So basically from one of the previous files in which the record was present, all the data from only that file has been copied to a new file after doing the update. So this is how we go ahead and update the records in the Delta table. All right, so you can see that this is the merge operation which has been performed. How many rows have been how many target rows have been updated? It's clearly mentioning it here. All right, so let's moving on. Now that we have seen that we can easily even update the data, now let's see that a very interesting, another interesting feature. So I keep saying it's a very interesting, these are all interesting features because they really can help us build a good and reliable data lake. Now see here, I'm going to use a feature called time traveling. Just now you have already seen that we are keeping the audit history. So that means that we now know that at what time what operation was performed. So what we are going to do? We are first, let me run this query and see what is the cancelled status for a particular flight number. So I'm going to apply some conditions and let's see what is the cancelled status for this particular flight. So we can see here the cancelled status is 1. Now, if I want to time travel, which means if I want to go and look at the previous version of the data, can I do that? Yes, I can do that using time traveling. So let's say if I want to look at, what was the cancelled status, let's say on a particular time or on a particular version number. So let me just show you the history once again of the table. So we have got 3 transactions which have happened. All right, so we have got transaction number 0, transaction number 1, and whether you call it version of the transaction number, it is the version number 2. Now, what I want to see is what was the status of, what was the cancelled status when the version was 1. So this means it is keeping a track of each and every, it is in fact keeping a track of the previous version of the data as well. So you can see there is 0, 1, and 2, 3 versions. So let me go and write the query. So it's exactly the same query that we are having, the same conditions, year, month, day, and the flight number. Plus, I am saying select cancelled status from airlinesdb.delta. Plus, I am saying version as of 1. So you can see there are 3 versions. Always, when you run the query on the table, it will always use the latest version. But then I now want to see what is the version, what was the what was the value of this particular record when the version number was 1. So this means I can now find out what was the previous version of the data. Think about, if you are coming from data warehousing background, you want to build slowly changing dimensions, and those kind of things. If you want to do change data capture, all these kinds of use cases can be easily solved using time traveling. All right, so I'm going to go and run this command by saying version as of 1. So this means show me the data for this particular flight when the version number was 1. And you can see here it was showing us the cancelled status in the latest version, which means the latest data. But actually, if you look at, if you look at the version number 0, in fact, version number 1, it is giving me that previously it was 0. Now in the latest version, it is 1. All right, so the cancelled status was 0 in the version number 1. It has become, the cancelled status has become 1 in the latest version. So this is the, something that I can get using time traveling, if I in the Delta Lake. So it is helping us to, it is keeping a track of all the previous versions of the data until and unless we go and delete that. So you might, a lot of you might have this question that, how do we, so will it keep, will it, if I'm running for 1 year, will it keep track of each and every activity? If you want, it will. So if you want, you can go ahead and delete the previous versions. It all depends on your requirements. All right. So let's move on and see that now we have get the data based on the version number, but I can also get to see the data based on timestamp. So let's say this is either you can use a version number, but if you know a particular date, let's say you can say, all right, what was the what was the actual data at this particular instance of time. So then you don't have to copy the exact timestamp. Maybe, you can write your own timestamp and say that, okay, show me the data, which was, what was the actual data at this particular time. So if you know how to work with slowly changing dimensions, if you use that in your projects, then you can very well understand, you can solve it. In fact, you can build up this use case using Delta Lake. All right, so I'll just go and put up this timestamp as well to see that, what exactly do we, can we get to see the output based on timestamp or not. Okay, so we can see here that based on timestamp as well, it is telling me that the cancelled status was 0. Okay, so this is how we can solve up the time traveling, we can look at the previous versions and we can even roll back. So if you want to roll back the complete data from the previous version, you can do that by using time traveling of Delta Lake. Okay, so now let's see, some performance improvements in Delta Lake here. Number one, you can see that, let me just quickly run a query here, and I'm going to, in fact, I'll just run the next one. Okay, so I'm going and running a a slightly bigger query, or slightly complex query where I'm doing a group by on the origin, airport, and the month. Then I'm also doing some sorting of the data. And then I'm counting the number of records. Plus, I'm going ahead. Notice here, I'm filtering of day of week equal to 1. Now, even if I'm using delta table, but still my data is partitioned using by airlines, and I'm not putting that as my condition here. Now what exactly does that mean? This means that now it will have to go and scan all the files in the in the transaction log, and it will have to see that where day of week equal to 1. All right, so this is pretty good as compared to Parquet, but still I have to go and look at the transaction log. If all the files contains day of week equal to 1, because obviously the data is scattered. So if the day of week equal to 1 is available in all the files, it is going to read all the files. Now, can I go ahead and improve it further? Yes, I can. Now think about, in relational databases, we use, let's say, clustered indexes. All right, so we organize the data in the clustered indexes, or we go and build up non-clustered indexes. So if we have got a clustered index, all our data, and let's say we keep column, let's say we use one column in the clustered index, let's say ID column. So, so that would mean that all the data will be sorted by that ID column. All right, so now, in the same way, just like we have clustered index in relational databases, we have got, a feature inside the Delta Lake, which we can utilize. So what I'm going to do, I'm going to go and, in fact, I'm going to go ahead and, reorganize the data based on day of week. So all the, day of week equal to 1, let's say Monday, all the Monday data will be there. It will start sorting the data based on day of week. So that would mean some initial files, or let's say first few files will have day of week, all the data of week one, of the day one, which is Monday. Then the next set of files will have all the data for, day of week equal to 2, then day of week equal to 3, and so on. So just like the cluster index, I'm going to go ahead and optimize my data. So what I'm going to write a command called optimize, and what this will do, this will go ahead and optimize my table, and it is going to order the data by day of week. So what is the command? We can use the optimize command and say z order by day of week. So this would mean it will take a bit of time. So you should not do this activity on, after every load. It is recommended that you do this activity, let's say every, let's say at the end of every week. So this is a background process, but still it will take a bit of time, because now it is going to read all the data and organize this data by day of week. Okay, let me go ahead and run this particular command. So it will take around a minute, even though I have only 5.8 million records, but still, while the other commands are running pretty well, because it is going to physically create new files. So that is why, it is going to reorganize all the stuff. Okay, now let me show you inside. While this is running, let's go back to, our data lake here. Okay, and if I go to the Delta folder, let me just go to airline equal to AA. So you can see here right now there are 6 files which are available. Okay, so this is the data. So we are going to, this data will, you can see now there is a 7th file that has been added. And just notice this one. Currently it is 0 bytes, because now it is, the data is getting written out. Just remember that in this particular file, data will be organized by day of week. Okay, just let's see that. So you can see that there are, these are the previous files, and now we have one single file with 15 MB. Now, does that mean that our data is scattered across all these files? No. Our our previous version of the data was available in these 6 files, which I've just, highlighted as a box here. But now the new data is all available inside this 15 MB file. Now this means this is the file that is, pointing to the latest version, but these are the files, which I've just highlighted. They are pointing to they have the older version of the data. So that means the older version of the data is there, the new version of the data is there in this new file. So this is how, because it has to keep a track of all the previous version as well. So it has not yet deleted the previous data, or in fact, it has not deleted the previous files. But now, if it has to read the data, first it will read the transaction log, see what are the files which are the latest files, and it's only going to read the files. So this means now if you run the query, it will only read the data from the latest file. These previous files are no longer required. So these previous files are only meant to, for the previous versions of the data. It is not meant for the latest version of the data. So if you want to keep the previous versions, you have to keep these files. If you don't want to keep the previous versions, we can safely go and then delete these files. Okay, and the deletion also should not happen, directly here in the data lake. It should happen via the APIs. Okay, so how we can go ahead and delete these previous files? Let's see that. Okay, so I can now go, first of all, let me just quickly run this query and see if the performance has been improved or not. So again, we have a where filter on day of week equal to 1. The previous command took 4.43 seconds, while this command, let's see how much time it is taking. It is 3 seconds. Now, because my data has been organized by day of week, and this would mean when I run this kind of filter, it is only going to read very few files while leaving the rest out. All right, now, so performance has increased. That's what we have seen. But we have also talked about that some of the files are previous versions which are no longer required. So this is where we can go and utilize a vacuum command to clear the previous versions of the data. All right, so I can, see all the latest, all the previous versions starting from version number 0. I can see all their data. But if I want to remove those previous versions, I can use the vacuum command. So let me go and say, let me use the vacuum command and put that on the table, vacuum airlinesdb.delta, and I'm just saying that, okay, let me not, I don't want to retain any previous version. So I'm saying retain 0 hours. So this means I do not want to retain any previous, any previous data. Okay, so you can decide on how many hours of data you want to keep, how many days of data you want to keep. So you can notice here, when I'm trying to delete all the previous versions, it is telling me that, are you sure you want to vacuum the files with such a low retention period? This would mean all the previous versions will be deleted. So that is why, if you are not sure, please use a value not less than 168 hours. What does that means? This means that keep the data, keep the previous 7 days of history. Okay, but again, let's say I'm using, I'm doing GDPR compliance. I have to clean up the data, on any previous version of the data. Then what I'm going to do, I'm going to say that, okay, at the retention duration check, I'm dot enabled equal to false. So if I go and say that, okay, do not check for, if I'm trying to delete the versions, do not block me or do not throw an exception, I'm removing this retention duration check. This would mean now I can go and delete all the previous versions of the data, let's say till the last 0 hours. I'm going to remove all the previous versions. Only the latest version will remain. So again, if you are doing GDPR compliance, this is something that can help you. All right, so it is going ahead and removing the files. And just notice that if you remember, we have got multiple files here. Now, as I told you, this is the only file which is useful. Rest of the files were meant for the previous versions. By doing the vacuuming, these files should also go away. Okay, let's just refresh and see whether it is done. Yep, you can see it here that only one file is remaining, which points to the latest version of data. The previous files have been removed. But also notice that because we have removed all the previous versions. So now I cannot, the version of command to, or in fact, I cannot do time traveling. Okay, because I have decided to remove all the previous versions, so no time traveling is allowed now. Okay, so moving back, you can see here it has went ahead and removed the previous versions. Now on the other side, I can just quickly go and run this query once again. And you can see here, I'm trying to run the query and saying that let me get, in fact, give me the version 0 data. But now it is throwing an error saying error while reading the file because it has removed the files which were associated with version 0. So now I only have the latest version files. I do not have the version 0 files. So because we have removed all the time traveling information. So these are some of the features inside Delta Lake. Let me show you a couple of more. So we have, quickly summarizing. So we have seen that it's an open format. So you can store the data in Parquet format. Plus the date, we'll also have the transaction log. We have seen it is performs much better than Parquet format. So we have, the counting is pretty fast because there are statistics. By if you are pointing to a specific query, or if you're writing, want to extract some limited data by putting up multiple conditions, it is much faster with the Delta as well. Plus, it also maintains all the audit history using which we can do time traveling. Plus, there is, we can do inserts, updates, deletes, and merge, directly on the Delta table. And we have seen how we can go and optimize the data by doing Z ordering and vacuuming. So that Z ordering physically reorganize the data, and vacuuming helps us remove the previous version of the data. Now, let me show you a quick couple of things here. Now, there are a couple of more features I'm going to show you. Number one is that a good feature of schema enforcement and evolution. And the number one is applying the constraints. So all the problems that I showed you about the data lake, this can be solved using Delta Lake. Okay, so I'm going to go and read a very small file. And let me show you what is there in that file. So you can see there is a very small table. We have got only 5 records and, with the ID, name, and salary. Now what I'm going to do, again, I'm going to save this data frame into Parquet and Delta format. So you already know we can apply the format as Parquet while saving, or we can apply the format as Delta while saving as well. So again, I'm taking these 5 records and I'm putting that in the Parquet format as well as in the Delta format. Now, let me show you that, let me go and create a new data frame, and I'll show you what does that look like. So you can see here, I have got a new data frame with 5 more records. So, the previous IDs were 1, 2, 3, 4, 5. Now we have 6 to 10 IDs available, and we have got a new salary here. Okay. Now what I'm going to do, I'm going to go and append this particular data in both the tables. Now remember here that the previous version, in fact, the data that we have stored contains ID, name, and salary columns. While this particular data frame that I'm going to append contains ID, name, and new salary column. So there is a column difference here. So let me go ahead and append the data into Parquet table. You can see here it has successfully went ahead and it has appended the data. Let me just go and quickly show you that if I want to read the data, so how does it look like? Okay, so you can see here, because there was no validation present. So that is why you can see that the one file contained, the 5 records with ID, name, and salary, while the second file, or in fact, the second data frame that I appended contained ID, name, and new salary columns. So this is a confusion, or in fact, this is a problem because there is no validation while inserting the data. So this is where comes Delta Lake once again. So what I can do, I can now try to save this, this new data frame, or I want to append this new data frame to Delta table. So let's say if I try to use the same data frame and I want to append this to the existing table, it is giving me an error saying a schema mismatch detected. So this would mean it has clearly identified that the Delta table has a different schema with ID, name, and salary columns, while the new data frame has an ID, name, and new salary columns. So now this means that it is helping us do the validation as well. All right. So this means that if I have to, if I want to merge these two, if I want to add a new column, or if I want to do schema evolution, I have to specifically say merge schema equal to true. Until and unless I specify this option, this will never allow me to add a new column, because obviously we don't want any data to be, any wrong data to get appended into the table. So we are saying, we are specifically mentioning that we want to merge the schema. So that is why, previously we are seeing the schema mismatch error. Now, if I'm saying merge schema equal to true, this will go and now merge the data. So this will create a new column in the Delta table. So this is helping me prevent, it is not helping me enforcing the schema, and it is, by not, this is the enforcement of the schema, and by applying the merge schema, I am doing schema evolution. All right, so this is helping me doing the validation as well. Now let me quickly go and show you the one last thing. So I'm going to go and create the table out of it. All right, and we can see the data as well. So I'm again creating I'm creating the employees table by using the Delta location. Now you can see we have got 10 records, we have got the salary column, and we have got the new salary column as well. Now what I can also do is I can go ahead and apply the constraints on these columns. So for example, I can go and say, in fact, if you see here, I'm just inserting one record. I can just go and run this one. So we have 10 records. It will easily go ahead and insert one more record. And now I can see there are 11 records. So pretty well, insert statement is working, very well here. Now on the other side, I'm going to go and alter the table employees. And this is my Delta table. I'm going to alter that. And I'm saying that let me add a constraint here. So by adding a constraint, I can prevent any wrong data to be inserted. So I can say, let me define a constraint very similar to the relational database word. So I'm adding a constraint and saying that, what is the check here? That the new salary can be null, or it should be less than 50,000. So this would mean that any date, any record, which will, either it can be null or it should be less than 50,000, then it is allowed to be inserted. Otherwise it will fail. Okay, so let me go and add this constraint on the Delta table. So you can see there are a variety of things we can do with Delta Lake. All right, so we have just altered the table by adding this constraint. Let me go and insert a new record into this table. Let's say, it's a junk employee, so 11 records are there, and we are saying the salary is 100,000. Now let me go and run this one and see if it works. Now you can see here that if you would have worked in Parquet format, this would have been possible, and this is which is not very right. But on the other side, I have now applied the constraint, very similar to relational word. So any data which is not following the, which is not within the constraint limits will not be allowed to be, to be inserted. So it clearly says invariant violation exception. So this is the constraint and it is violating these conditions. So in the previous notebook, we have seen things like, the comparison with the Parquet format, time traveling, optimizing, vacuuming, and here we have seen things like schema enforcement and evolution, as well as applying the constraints on the table. So Delta Lake is something that can help us build a reliable environment inside our data lake, and making sure that we are following all the policies, making sure that there is a rollback option available, and making sure that no data is getting in without going through the pre-checks. All right, so this brings us to the end of this particular session. So once again, a special thanks to Microsoft and all the sponsors for supporting the data platform, for supporting the data platform summit. And in case you wish to, there are multiple ways in which you can win the prizes. So information is there on your screen. I hope you enjoyed this particular session. So it's a very, very interesting component, and I would really encourage you that you go and look into this one. So thank you so much for joining in. I hope you enjoyed the session, and keep enjoying at the Data Platform Summit. Thank you and have a wonderful day.